Hi, in this video we are going to be reviewing absolute value, how to model it, and how to use it with operations of integers. So to start off, the definition of the absolute value of a number is its distance from zero. So we're going to be talking about how far away does this number exist on the number line from zero. So we're just basically counting the spaces between the number and zero on that number line. We represent it as the absolute value of x. It looks like this. So we have these bars that are called your absolute value bars. They kind of look like parentheses if you recall. When we group a number like this, it's putting it in parentheses, but we have these straight lines instead. And when you see the straight lines, that takes the absolute value of something. So when we see those bars, we read it as the absolute value of x. And of course, it's not always just going to say x there, but x is just a placeholder for us. So x could be any number that we want to put inside. So I could put in the absolute value of 2. And 2 is 2 spaces away from 0, so the absolute value of 2 is 2. Or I could take the absolute value of -2, and -2 would be 2 spaces away from 0, so the absolute value of -2 would also be 2. So it's just taking that number, putting it in the bars. It's like a grouping, so it's keeping it all together, and we count how far away is it from 0. So we're going to look at that with the number line to help us visualize it. So my first question for you here is, how far is -4 from 0? Well, I'm going to draw that here on our number line. From 0 to -4, I would have to count 1, 2, 3, 4 numbers to the left here. And that gets me 4 units away from 0. Now, in the opposite direction, how far is +4 from 0? If I want to start at 0 and go to +4, that would be 1, 2, 3, 4 spaces away from 0 as well. So they're both 4 units away from 0, and what that tells us is that the absolute value of -4 is 4, because it's 4 units away from 0. But it also tells us that the absolute value of +4 would also be 4. So something that you might notice is that it makes our answer become positive here, but it's not necessarily just the rule to remember that the number will always be positive, because then we get into cases like these two examples. And something that you might see that's a little bit different is that now I'm taking the opposite of the absolute value. So what do you think is going to happen if I have a negative sign on the outside of my absolute value bars? Well, what we can think about is that we're taking the opposite of whatever the absolute value of 4 is. Well, we know the absolute value of 4 is 4, so I'm going to bring that part down, but I'm also bringing down the negative sign here to indicate that I'm taking the opposite of my answer. So really the final answer here is that the negative absolute value of 4 is -4. So it's a little bit messy if you think about it in your head, but we're just taking the opposite of our final answer here. So again, I'm taking the opposite, so I'm bringing my negative sign down, and I'm taking the absolute value of -4. Well, the absolute value of -4 is 4, so that's my answer to the inside of my bars, but that negative sign's on the outside, so it needs to come down, and my answer here is -4. So if there's no sign in front, we know it's positive, we get that positive answer. When there is a negative sign out front, we know that our answer will be negative, so we need to put that negative sign there. So that's just something to take a look at as you're going through examples, just paying attention to where that negative sign exists. So I'm going to have you pause the video and try to complete the following 6 examples on your own. When you're ready, you can press play to listen to the explanation. If you don't feel like you're ready to try it on your own yet, just keep listening. So now we're going to go over these. The absolute value of -34 is our first problem. And in your head, you just want to ask, well, how far away is -34 from 0 on the number line? Well, that would be 34 spaces away, so my answer here is just 34. The absolute value of 12 would be 12 spaces away from 0 on the number line, so the answer is 12. Here, we're taking the opposite of the absolute value of 23. So I bring my negative sign over right away, and the absolute value of 23 is 23. So my final answer here is -23. In the next example, we have the opposite of the absolute value of -2.5. So I'm going to take the opposite of my answer, the answer to the the absolute value of -2.5 would be 2.5, because it's just 2.5 spaces away from 0. But because that negative sign was out front, it needs to come to the front of our final answer here. In the next example, we have the absolute value of -245 thousandths. That's a really tiny number. But again, it still works the same way. This number would be 245 thousandths away from 0 on the number line if you counted it. That's the distance. So our answer here is positive 245 thousandths. Now in this last example, hopefully you were able to figure out this challenge. I wanted you to tell me what could x equal here. So it's saying the absolute value of something, or of x, is 13.7. Well, there's two answers here because I can say that the absolute value of 13 and 7/10 would get me 13 and 7/10. So I know that that's true. But I also know that if I took the absolute value of negative 13 and 7/10, I would have the same answer on the outside of 13 and 7/10. So what that means is that for this problem, we can say that x could equal 13 and 7/10, or x could equal negative 13 and 7/10. So we really have two different answers here, and I can write it as x equals 13 and 7/10 or x equals negative 13 and 7/10. So hopefully you're able to try that challenge problem and see if you maybe at least got one of the answers right, but we do have two correct answers here. So we're going to move on and look at how we can model this on the number line, and we kind of saw it when I first explained it, but we're going to do this again. When we model absolute value, you just need to have a number line sketched and use an arrow. You're always going to start your model at the number 0, because if you think back to our definition of absolute value, it's a number's distance from 0. So we're going to actually draw the distance from 0 to the number that we're modeling. So in this example, we need to model the absolute value of negative 3 equals 3. So what that means I'm going to do is I'm going to start my model at 0, and I'm going to go to the number that's in my bars. So I'm going to go to the number negative 3. To do that, I'm starting at 0 and moving left to negative 3, so my arrow needs to face the left. And if you notice, I'm putting the bars around my arrow. That's just reminding me that I'm taking the distance there. And you could go ahead and count. The distance from 0 to negative 3 is 1, 2, 3 spaces. So this is proving that the absolute value of negative 3 is positive 3. How many spaces long is the arrow? Well, we just counted. It was 3. And whatever your length of your arrow is, it's going to be the absolute value of the number you're looking to find. So we model based on the number in the bars, and our answer is that actual distance of the arrow. So if you feel like you understand that, go ahead and pause the video and try these 3 models. If you're still a little unsure, maybe listen to the first one and then pause. In this first one, it's asking us to model the absolute value of 4 is 4. So I'm going to start at 0, and I'm going to go to the number that's in my bars, which is positive 4. So I need to move to the right to go from 0 to 4. That means that my arrow should have a length of 4. If I count 1, 2, 3, 4. Yes, this has a length of 4, which means the absolute value of 4, its distance from 0, was 4. So this is the model that we need to draw. In the next example, I'm taking the absolute value of negative 1. So I'm starting at 0, I'm going to negative 1, and to go from 0 to negative 1, I need to move to the left on my number line. And so my distance from 0 to negative 1 is just 1, and that's what that is showing us, that the absolute value of negative 1 equals 1. In this last one, we have the absolute value of negative 1/2. So again, we start from 0, and we go to negative 1/2. Well, that's not fully all the way over to negative 1. It's about halfway in between here, so I'm going to add it to my number line between 0 and negative 1. That means I'm just going here. I'm only moving half a space to the left, so my absolute value of negative 1/2 is positive 1/2. This could also be rewritten as the absolute value of negative 5/10 equals 5/10, because we can change that fraction into a decimal. So we use this to help us answer questions like this, where it says the absolute value of 3 would be equivalent to the distance between. And we have 3 different choices. So I'm going to start with choice A, and the distance between 1 and 2, I can see is just 1 space. In my second example, I have the distance between negative 3 and positive 3. If I count that on my number line, that's 1, 2, 3, 4, 5, 6. That's 6 spaces between negative 3 and positive 3. And then in my last one, I have the distance between 5 and 8. Well, that's 1, 2, 3 spaces. So now that we've counted the distance between all 3 of those options, the question had said the absolute value of 3 is equivalent to the distance between. So some words that pop out here. Well, the absolute value of 3 would be written like this. When it says equivalent, we want to set it equal to something. Now think back to what we just learned at the beginning of the video. What is the absolute value of 3? It's 3. The only set of numbers here that had a distance of 3 between them was option C, 5 and 8. There was 3 spaces between them, so its distance between 5 and 8 is equivalent to the absolute value of 3. The last thing that we want to look at is completing operations using absolute value signs. So you might have in the past learned about the order of operations, and sometimes we abbreviate them using GEMDAS. And GEMDAS stands for groupings, exponents, multiplication and division. I'm just going to use a times symbol and a division symbol, and then addition and subtraction. And when we follow the order of operations, we always want to move from left to right in our equation and go in this order, working from groupings all the way down to the bottom of our list. So what that means is groupings are anything like parentheses, absolute value bars, or brackets. And so what we're really concerned with right now are the absolute value bars. They're treated as a grouping, so if you see anything in the bars, you want to do that option, or you want to take care of that first. So when we have something like this, where we have an operation inside of the absolute value bars, we've got 6 minus 2, it's in the bars, that means we need to take care of it first. So the absolute value of 6 minus 2, I'm going to bring my absolute value bars down, and I'm going to take the operation and say 6 minus 2 is 4. And if you weren't sure, you could look on the number line and start at 6 and then subtract 2. That means we move 2 spaces to the left, and I end up at 4. So now I have the absolute value 4. Well, we're not completely done. Now I need to take the absolute value of that. The final answer would be 4 because 4 is the absolute value of 4. In my next example, I have the absolute value of negative 3 plus 6. So to do this operation inside, I'm going to start at negative 3 on my number line. And because I'm adding 6, I'm going to count 6 spaces to the right. And that means that negative 3 plus 6 is going to equal positive 3. So now in my bars, I have an answer of 3, but I still need to take the absolute value of that, and the absolute value of 3 is 3. And I'm just using this number line down here to help me show my work. It's not something that you have to do. It's just really helpful when we do integer operations. In the next example, we have the absolute value of negative 3 times 7. So again, I have an operation inside the bars. So I want to do negative 3 times 7 first. Well, I have 3 times 7, which is 21, but I'm doing a negative times a positive, and when I have a multiply a negative by a positive, my answer becomes negative. So I'm taking the absolute value of negative 21, which is positive 21. Finally, in this last example here, I have the absolute value of negative 16 divided by negative 4. So I'm going to do the operation inside first. Negative divided by a negative is a positive, and 16 divided by 4 is 4. So I get 4 inside. I have not taken the absolute value yet, so I need to show that step. But now I'm going to take the absolute value of 4, which again is 4. So if you have operations inside, you need to take care of your groupings and do them first. Now we're going to continue using that GEMDAS rule and use our number line to help us complete these other examples. But something that's going to look a little bit different is now we're going to have operations that are outside of the bars. And so what I mean by that is in this first example, we've got the absolute value of negative 22 plus the absolute value of negative 13. So now I have 2 sets of absolute value bars, and in between them I've got an operation. They're outside of those bars, so we need to take the absolute value first and then complete the operation that's on the outside. So if we try this example first, the absolute value of negative 22 would be 22. I'm going to bring down the plus sign because I haven't used it yet, and the absolute value of negative 13 would be positive 13. In the next example, I have the absolute value of 15 minus 15, and then on the outside of those bars I have minus 8. So I have a few different steps to take care of here. First, I need to do the operation that's inside the bars, so 15 minus 15 is 0. And then I'm going to bring down what I haven't used yet. Well, the absolute value of 0 would be 0. And then I have this problem of 0 minus 8. Now we can use our number line to help us. If I start at 0 and I want to subtract 8, that means I need to count back to the left 8 spaces on my number line. So 0 minus 8 would be the answer of -8. Oops, we never finished this first one. My bad. 22 plus 13. We had to add those together. That would get us a final answer of 35. Sorry about that. I totally missed that. Here's our final answer circled. In the next example, we have 2, and then right next to it, we have absolute value bars with a 7. So I have a number outside of the bars. Something that trips people up here a lot is that there's no operation between them. But if we don't see anything in between a number and a grouping, we imply that there is multiplication next to them. So I'm going to rewrite this problem as 2 times the absolute value of 7. So before I can do the operation that's outside, I need to take the absolute value of 7, which is 7. So I'm rewriting it as 2 times 7, and 2 times 7 is 14. And in this last example, I have 15 divided by the absolute value of 3, or the absolute value of -3. So before I can do the operation that is outside of the bars, I need to take the absolute value of -3, which is +3, and 15 divided by 3 is 5, and that's my final answer. So just remember to follow GEMDAS, use a number line as a tool for yourself. You do not need to model it unless it says to model, but it is something that's really helpful, especially when we're adding and subtracting integers and moving left to right on the number line. Thanks so much for watching.